have you noticed how autonomous vehicles are becoming more than just a concept? They're being tested on real streets, even offering rides in cities like San Francisco, Shanghai, and Dubai.
Yeah, I've seen some of those self-driving cars in the news. It's really cool that they can drive themselves.
You know, Jason, whenever I see one of those self-driving cars being tested on the streets, it hits me. We're living through a major shift. Not long ago, this would have seemed impossible. But now it's happening. It's amazing how quickly things change.
But tell me, Rachel, what actually lets them see the road? How do they know what's happening around them and make decisions without a human behind the wheel?
Now that's something a lot of people wonder about, Jason. It's not just one piece of tech running the show. It's a bunch of systems working together. You've got cameras, sensors, radar, LiDAR, and some really smart software all helping the car understand what's going on around it. The car has to do three main things: see its surroundings, decide what to do, and then actually do it. GPS tells it where it is, radar checks how far things are, LiDAR builds a 3D map of the environment, and computer vision helps it spot stuff like traffic lights, road signs, pedestrians, even how other drivers are behaving. It's all about giving the car the tools it needs to drive safely and smoothly.
That makes sense. I can see why GPS would be useful. It gives the car a sense of location, like a digital map to follow. But that alone wouldn't help it react to a sudden obstacle or a red light. It is critical for responding to real-time situations. You also mentioned something called LiDAR. I've heard the term, but what exactly does it do?
Let me break it down. LiDAR stands for light detection and ranging. Think of it like radar, but instead of using radio waves, it uses laser pulses. An autonomous vehicle equipped with LiDAR sends out thousands of laser beams every second in all directions. These beams hit objects around the car, like buildings, pedestrians, or other vehicles, and bounce back. By measuring how long each beam takes to return, the system calculates the exact distance to each object.
So it's basically scanning the surroundings non-stop, like the car is constantly checking how far everything is from it. That's pretty intense.
Exactly. And once it gathers all that distance data, it builds a super detailed 3D map of the environment, what we call a point cloud. That helps the car know where obstacles are, how far away they are, and what shape they are. It's especially useful for spotting things like curbs, lane markings, or even nearby vehicles in the dark. But LiDAR isn't perfect. It's expensive, and weather like heavy rain or fog can mess with the laser signals. That's why it works best when combined with other tech like computer vision and radar, so the car gets depth from LiDAR, visuals from cameras, and motion sensing from radar.
But Rachel, that makes me wonder. We humans mostly rely on our eyes to drive. How do these self-driving cars deal with visual information? I mean, how do they actually see and make sense of what's around them? Like, how does the car recognize a stop sign or a person crossing the street?
Glad you brought that up, Jason. A driverless car understands its surroundings, kind of like how our brains work with our eyes. It pulls in information from a bunch of sensors to make sense of the world. It all starts with cameras, usually several of them placed around the car to give it a full 360-degree view. These cameras are constantly taking in images of the road, signs, traffic lights, people, everything.
So it's like the car has eyes everywhere, always watching what's happening around it? I mean, imagine if you were walking down the street and you had a perfect awareness of every car, pedestrian, and traffic light around you, all at once, and could instantly react if something changed. That's what this tech is doing. It's not just smart, it's hyper-aware. And the fact that it can keep doing that without getting tired or distracted, that's next-level stuff.
Exactly. And those images are then processed using deep learning, especially something called convolutional neural networks. These are designed to function a bit like the human visual system. On top of that, radar comes into play. It's really good at detecting motion and speed, even in bad weather. It doesn't give as much detail as cameras or LiDAR, but it adds an extra layer of safety, which is critical.
Interesting. So each sensor has its own strength, but I guess no single one is perfect on its own.
Right. That's why the real magic happens when all these inputs, cameras, radar, LiDAR, GPS, and motion sensors, are blended together. This process is called sensor fusion. It creates a super detailed, constantly updating model of the car's surroundings. That's what helps the vehicle stay aware of everything around it in real time.
Okay, so once the car has that full picture, what happens next? How does it decide what to actually do?
With a full picture of its environment in place, the autonomous vehicle then begins to think. This is the planning stage, where it decides what to do next. Should it slow down, change lanes, stop at the crosswalk? Using a combination of rule-based logic and neural network-based prediction models, the vehicle evaluates all possible outcomes and chooses the safest, most efficient action. It anticipates the movements of other vehicles, pedestrians, and cyclists, much like a skilled driver does, but with data-driven foresight. It uses a mix of rules and prediction models to figure out the safest and smartest move, kind of like a skilled driver who's thinking a few steps ahead.
So it's not just reacting to what's in front of it. It's actually thinking ahead, kind of like how we plan our next move while driving.
Exactly, Jason. These cars are like super strategic drivers, always predicting what's next, whether a cyclist might swerve or a car might brake suddenly. Using a blend of rule-based logic and AI predictions, they pick the safest, smartest move in a split second. It's like having a driver who's always 2 steps ahead and never blinks.
That's absolutely wild, Rachel. So these cars are like chess grandmasters, always planning their next move. But once they've got that brilliant plan, how do they actually pull it off? I mean, how does a car physically steer itself, hit the brakes, or speed up without a human touching the wheel or pedals? That part blows my mind.
Great question. That's where the control system kicks in. Once the AI makes a decision, it sends precise commands to the car's physical components, steering, throttle, brakes, with pinpoint accuracy. We're talking millisecond-level precision to ensure the car moves smoothly and safely, whether it's navigating a tight turn or stopping for a pedestrian. The car relies on high-powered processors and sophisticated software to crunch all that sensor info instantly. Some systems even tap into the cloud to update maps, share live traffic data, or learn from other vehicles' experiences. It's like a supercomputer on wheels, constantly optimizing how it drives.
Okay, hold up. Between all these sensors, AI predictions, and supercomputers, it sounds like these cars are practically sci-fi. With all this incredible tech, I'd assume we're pretty much at the point where cars can just drive themselves completely. No human needed, right? Are we there yet?
Not quite yet, but we're getting close. Most commercial vehicles today are at level 2 or 3 autonomy, meaning they still need a human ready to take over. However, level 4, where no driver is needed in specific conditions, is being tested in places like Shanghai, where robo-taxis shuttle passengers from Pudong Airport to downtown, or in the US, where Waymo's rolling out services in cities like Phoenix and Dallas.
That's incredible, Rachel. It's like every part of the world is putting its own spin on this tech. It's starting to feel like a race to the future. So, zooming out, what's the big picture here? Where's all this headed?
The big picture? We're in the middle of a transportation revolution. Every mile these vehicles drive, they're learning, improving, and getting us closer to a future where roads are safer and driving is effortless. It's not perfect yet. There are still hurdles like regulations and edge cases, but the road ahead is looking pretty exciting.